Okay, flip over to the back of your star chart. So where you took notes on Monday, it should be on the back now. We're gonna work on the blank side. So you're gonna fold your star chart to create 3 columns, 3 rows. This is what your chart should look like. You should have a total of 9 sections for you to take notes. We're gonna start in this first section up here. And in this section, we're gonna put our rotation and reflection rules. So at the very top, label it reflection rules. Okay, underneath it, we're gonna put our 2 reflection rules. Our first reflection rule is the x-axis reflection. So put x-axis, xy goes to x negative y. Underneath it, you're gonna put your y-axis reflection rule. xy goes to negative xy. Okay, so I taught you guys a trick in class to memorize these. The x-axis, the opposite one will be negative, so the y is negative. The y-axis, the opposite one is negative, so the x will be negative. Go ahead and break your box up right here. And underneath it, we're gonna put our rotation rules. Okay, so for our rotation rules, we're gonna start with our 90-degree rotation, which is xy goes to y negative x. Then our 180-degree rotation, which is xy goes to negative x negative y. And finally, our 270-degree rotation. xy goes to negative y x. We're not going to include our 360 rotation in this box because that's the easiest one to memorize. So 360 does not change. It stays the same. xy goes to xy. But we are going to put notes about congruence and orientation. Underneath the 270, I'm going to put preserves congruence. This is true whether I reflect or rotate an image. So what it means is if I reflect or rotate an image, it's gonna stay the same size. I don't change the size of it. It remains congruent. Underneath this, I'm gonna put does not preserve orientation. And what this means is if I reflect or rotate an image, it's not going to stay facing the same direction. So when I reflect it, the image is going to flip over. When I rotate it, it's going to turn. It doesn't stay facing the same direction. In our next box, we're going to take notes on dilation. So go ahead and title this box dilation. And I'm going to put a note reminding myself how I find my scale factor. So put scale factor equals, and when we find our scale factor, we make a fraction. The prime is on top, the numerator. The non-prime is on the bottom, the denominator. So prime over non-prime. And in this particular box, we're going to talk about dilations when the scale factor is less than 1. Now on STAAR, this is called a reduction. Or they'll say that the figure or the image was made smaller. Okay, right here underneath, I'm going to draw a small graph to give myself an example of what it looks like when they give me a graph on my STAAR tests. Okay, and I'm going to draw a rectangle. My original one is going to be the larger rectangle. And let's go ahead and label it rectangle A, B, C, D. And then I'm gonna apply a reduction, or I'm gonna make it smaller. So I'm gonna draw a rectangle that's inside of this rectangle, but a little bit smaller. And I'm gonna label it A prime, B prime, C prime, D prime. Okay, so I applied a reduction using a scale factor that was less than 1. My image, or my shape, my rectangle, got smaller, so the A became A prime, the B became B prime, the C became C prime, and the D became D prime. Right here to the side, I'm going to give myself an example of what the rule would look like. When I'm writing dilations, it always begins with XY goes to. And then I have a number, X, comma, the same number, Y. So when I have a dilation, my rule is written with the number that's my scale factor before the X and before the Y. Then down here in this the remaining space of this box, I'm going to put notes about congruence and orientation. So if I apply a reduction, or I make a shape smaller, it does not stay the same size. It's getting smaller. The way we say this on STAAR is we say it does not preserve congruence. So right here underneath, does not preserve congruence. The image does not rotate, it's not reflected. And the way we know this is by looking at our graph. When we made it smaller, letter A stayed in the same position that letter A was. Letter B stayed in the same position that letter B was. Letter C stayed in the same position that letter C was. And letter D stayed in the same position that letter D was. It didn't change direction. The way we say this in STAAR is it preserves orientation. Now in my third box, again, I'm going to talk about dilation, so label it dilation. And I'm going to remind myself how to find the scale factor, just like we did in the box before this. So scale factor is prime over non-prime. This time, however, instead of talking about the scale factor being less than 1, I'm going to talk about the scale factor being greater than 1. And in STAAR, this is called an enlargement. Or they can say that the shape was made bigger. We're going to draw another graph to show us that example. This time, my original rectangle is going to be the smaller one. So let's start with that one first. A, B, C, D. I'm going to apply an enlargement, or I'm going to make it bigger. Label A prime, B prime, C prime, D prime. So what happened here is my scale factor was greater than 1, so it made my shape bigger. Or it was an enlargement. We are going to put in a note here for how to write the rule. So xy goes to, same thing as before, a number x, comma, number y. The scale factor goes before the x and before the y. Down here, I'm going to put the same notes I put about congruence and orientation. That still applies when the scale factor is greater than 1. So they do not preserve congruence, but they do preserve orientation. In these two boxes underneath, we are going to talk about translation. So label both of them translations. In this box, we're gonna put an example of what it looks like on a graph. So draw a graph, and this time make it a little bit bigger. For translations, we need to have some room to show that the figure is shifting. And we're gonna make our original shape down here. So draw a rectangle down there. And label A, B, C, D. Then we're going to shift this to the right and up. So draw your new rectangle right here. When you draw the rectangle, try to make it look the same size and then label your new letters. So A prime, B prime, C prime, D prime. Then we're going to draw an arrow just to tell us in which direction it moves. So it went this way. This is one of the strategies we use in class. Our next arrow that we draw is going to tell us whether it went left or right. This particular translation went right. And I always tell you guys that with that right arrow, put what it means. So right means x plus. And I'm going to leave a blank. That tells me to fill it in with a number. Then draw your arrow going up. Again, do the same thing. It's our strategy. Y plus a blank. Underneath this, I want to write an example of what the rule should look like. So the rule for translation start with xy goes to x plus or minus a number, so either adding or subtracting, comma, y plus or minus a number. And I'm going to leave that blank so we can fill in the blanks depending on what our STAAR test gives us. In the next box, I'm going to tell myself what the key words mean in case I have a word problem. So the word left, if they tell me that it was translated left, means x minus. If they tell me that it was translated right, that means x plus. If they tell me it was translated down, that means y minus. And if they tell me it was translated up, that means y plus. Underneath this, I'm going to put my notes for congruence and orientation. So translations are the special transformations that preserve both. No matter what, translations always preserve congruence No matter what, translations always preserve orientation. Okay, what this means is when I move an image or when I shift an image, when I translate an image, just like we did here in this example, it stays the same size and it stays facing the same direction. So the A stayed on the top left. On this new one, it also stayed on the top left. The B was on the top right, stayed on the top right. C was on the bottom right, C is on the bottom right. And D was on the bottom left, D is on the bottom left. In this third section, I'm gonna title this one Angles. So this year we learned 3 angle theories. The first one we learned was the triangle sum theory. So what I want you to do is draw just a regular triangle. And I want you to tell yourself that in a triangle, the angles always equal 180 degrees. We use NSolve to solve these types of problems. So I'm going to put an example of that. NSolve, or menu 3-1, a number, which is one of the angles, plus a number, which is the other angle, plus x, which is the missing angle, will equal 180. And then in NSolve, you always have to put comma x. The second angle theory we learned this year was the exterior angle theory. For this one, you're going to draw a triangle, but your line is going to stick out with an arrow. And if you're my student, we just went over this yesterday. So this is the strategy where I taught you to circle the 2 things you're given, the 2 angles on the inside. These 2 angles are added together. You draw an arrow pointing to the outside because when we add these 2 angles together, it equals the outside. I'm going to tell myself that. I'm going to put a little note. Add the 2 circled angles, whether it's a number or an X, you add them. They equal the outside angle. Okay, and then we solve this in NSolve. And the last angle theory that we learned this year was regarding parallel lines. So draw 2 parallel lines. And then we're going to draw a transversal going through it. And for this one, we learned that we have equal angles going across from each other, diagonally across from each other. We're always going to have a big angle, so I'm going to label that with a B. And the one directly across from that is also a big angle, so they'll be the same size, same angle degree measurement. The other 2 are smaller angles. So I'm going to put an S for small, and directly across from it, it's going to be the same size. So the small angle is the same as the small angle. The big angle is the same as the big angle. To fill in the other 4, you literally copy and paste it down here. So on the top left here, I have a big angle. This is a big angle. Top right, I have a small angle. This is a small angle. Bottom left, I have a small angle. So bottom left, I'll have a small angle. Bottom right, I'll have a big angle. So bottom right, I'll have a big angle. Now they're always going to give you one of the angle measurements. To get the other one, we always subtract from 180. So 180 minus the angle you're given is the other angle. So we're just going to tell ourselves we subtract from 180. In this bottom left section, I'm going to put notes about scatter plots. So go ahead and label this box scatter plots. And I'm going to draw 3 graphs. So let me start by setting that up. The first one, I'm going to make it an example of a positive linear association. What that looks like is I have points scattered, but going in a positive direction. So over here on the side, I'm going to call this positive and linear. The second one, I'm going to make it an example of a negative linear association or correlation. This time we're going to go in a negative direction. And we're going to label this negative linear. The last one is going to be my example of a no correlation scatter plot. So this one should just have points scattered all over in no pattern. They do not form a linear trend. And we call this no correlation. Or non-linear. In this middle section, I'm going to put examples and notes on Pythagorean theorem models. So title this box Pythagorean theorem models. Pythagorean theorem models are when they give me the 3 squares and they're asking me if I join those squares, will it or will it not form a right triangle? So I'm going to draw an example of what that looks like. 1 square here, 1 square here, and then another square here, but in a slanted direction. I'm going to put a note here on the side because the biggest mistake we make is we label C as the wrong square. What you have to remember is the biggest square is always C. Even if it's not the biggest number, they like to trick us that way. So label the biggest square C. The other 2, you can choose which one is A, which one is B. So I'm going to choose to call this one A and this one B. And then you use whatever numbers they give you to make a Pythagorean theorem equation. The Pythagorean theorem equation should look like this. A squared plus B squared equals C squared. I'm going to put a note to remind myself that we only put squared if it doesn't already have it. And I'm going to remind myself of 2 more things underneath. If I get a true answer in my calculator, that tells me that the 3 squares make a right triangle. If I get a false in my calculator, that reminds me that that tells me that the 3 squares do not make a right triangle. In this last box, I'm going to use it to put notes on surface area. So what I want you to do is cut this box in half, because when we're talking about surface area for prisms specifically, we have two different formulas. The first one that we can use is called a lateral surface area formula. The second one we can use is called a total surface area formula. And it depends on what the problem is asking us to do. So in each box, we're going to draw our T-chart that we use in class, our graphic organizer. And we're going to start with lateral surface area first. So for lateral surface area, the first thing you should do as soon as you see that the problem says lateral surface area is go to your star chart and find your formula. And then your formula goes here. S equals pH. Once you've written this down, if they give you a picture or if they give you a word problem, identify your height, and your height goes here. Always, always, always cross off the height on either the picture or in the word problem so you don't reuse it. Then you draw your base. And because we use this graphic organizer, this T-chart, for triangular and rectangular prisms, your base will either be a rectangle or a triangle. In this section, you're going to solve for P, perimeter. So I'm going to put P equals perimeter. And it doesn't matter what shape I have to work with. Perimeter means to add all sides. Once you have the perimeter and you've solved for it, then you're going to go to this last box and you solve using your formula. Then I'm going to go to my total surface area section, and I'm going to do the same thing. I'm going to fill it out the way I'm supposed to fill it out when I'm answering a question about total surface area. The first thing you do is you go to your star chart, you find your formula, it goes in this box right here. S equals pH plus 2b. Then you go to the picture or the word problem and identify your height. It goes right here. Just like before, cross off the height on the problem, whether it's a picture or a word problem, so that you don't reuse it. Then you're going to go here, draw your base. Same thing, it's either going to be a rectangle or a triangle. In this section right here, you're going to solve for perimeter, so P equals perimeter. And I already told myself what it means, so I'm not going to do it again. Instead, what I'm going to do is put B equals area, because I have to solve for B for total surface area. But I'm going to tell myself how to do it. So if I'm given a rectangle, draw a rectangle, and inside put how to find area, length times width. If I'm given a triangle, I need to make it a little bit bigger, but if I'm given a triangle, it's going to be base times height divided by 2. So we only divide by 2 if we're using a triangle. Once I have perimeter and area, I can solve in the last section. So solve. This is what your chart should look like now that we're done. Make sure you have all this information written down correctly. All of this will help you be successful in April when you take your STAAR test. Ethan, I'm talking to you. Make sure your paper looks like mine.